Now we're going to talk about graphing using reflections. And so here's an example of a function f of x. It's this blue function here. And then it's reflected across the x-axis, or the y-axis. That's a horizontal reflection. It comes like that. And if it goes across the x-axis, that's the vertical reflection. It's going down like that. So I want to point out that the horizontal reflection means we're going to have the negative of the x power of the x, power of x value, but in the vertical reflection, it's just the negative of the function. So reflections, given a function f of x, the function g of x equals negative of f of x is a vertical reflection of the function f of x, sometimes called a reflection about or over or through the x-axis. So that's what we see here. This kind of a teal color, I'll call it the right color. That is a reflection of this blue one, the original f of x, across the x-axis. And then we have, given the function f of x, the function g of x equals f of negative x is a horizontal reflection of the function f of x, sometimes called a reflection about the y-axis. So it brings it on the other side of the y. So it's low on the left side and it goes up high. Now it's high on the left side and it goes down low. So how to graph a vertical and horizontal reflection. Multiply all outputs by -1 for the vertical reflection. This is the same. Let me see if I can get that closer now. I don't like that. This is the same as multiplying the entire function by -1. This new graph is a reflection of the original graph about the x-axis. Then multiply all inputs by -1 for horizontal reflection. This is the same as multiplying the input variable by -1. The new graph is a reflection of the original about the y-axis. So reflect the graph of f of x equals the absolute value of x minus 1 vertically and horizontally. So our original function is going to be like normally an f of x is going to be going here, but it's got the -1, so it's going to be going here. There we go. Roughly drawn somewhat decently. Now, if we're going to talk about the vertically reflection, that means it's going to just be coming down here. And if we talk about a horizontal reflection, that's going to be interesting. So the x values become the negative of what they were, so that means it's going to be over here instead. Let's see if I could change colors to an orange, maybe. There we go. If I do this, I lose the whole line, but such is life. Okay, so this would be f of negative x, and then this is negative f of x. Okay. Using the function f of x, given the table, create a table for the functions below. G of x is the negative of f of x. So that means each x value becomes opposite of what it was. So -5, -10, -15, and -20. And in the second case, we have f of negative x. So that's going to be a little more complicated because we don't have a -4, but negative of -2 is +2, so that's 15. Negative of 0 is still 0, so that's going to be 10. Negative of 2 is -2, so it's 5. And we don't have a value for f of -4, so we'll just say not available. Not applicable. And let's talk about even and odd functions. A function is called an even function if for every input z, f of x equals f of negative x, the graph of an even function is symmetric about the y-axis. So it reflects over itself, basically. A function is called an odd function if for every input x, f of x equals the negative of f of x. The graph of an odd function has symmetry about the origin. So an example would be like a parabola for the even function. That's an example of one. And then like a cubic function. So it should be f of negative. I think it's an f of negative of f of negative x. Like that. That's more correct. Okay, how to determine the graph of a function is even, odd, or neither. And so determine if it satisfies f of x equals f of negative x. If it does, it's even. Determine if it satisfies f of x equals the negative of f of negative x. If it does, it's odd. If the function does not satisfy either rule, it is neither even nor odd. So is this function even, odd, or neither? So let's look at f of negative x. That's going to be negative x to the fourth plus 3 times negative x squared plus 7. Well, negative x to the fourth, that's just going to be the same as x to the fourth. And negative x quantity squared, that's just x squared plus 7. So that's going to be equal to our original f of x. So this is an even function. And we'll stop with that.